Welcome to your interactive study guide on waves and quantum mechanics. In this session, we will explore the revolutionary concepts of the photoelectric effect, wave-particle duality, and how light and matter behave in ways that defy classical physics. Get ready to bridge the gap between the macroscopic and microscopic worlds. Let us map out the core ideas. First, the photon model treats light as particles of energy. Second, the photoelectric effect demonstrates that electrons are only emitted if light exceeds a threshold frequency. Third, wave-particle duality means light and matter have both wave and particle natures, with de Broglie quantifying the wavelength of moving particles. Turning to our core notes, remember that photon energy is directly proportional to frequency. The work function is the energy needed to free an electron, and the threshold frequency is the minimum frequency that can cause emission. Einstein's equation ties it all together: incident photon energy equals work function plus maximum kinetic energy of the emitted electron. Let us walk through the process. First, a photon hits the metal. Its energy is transferred to an electron. Only if that energy is at least as large as the work function does the electron escape. Any extra energy appears as kinetic energy. The ejected electron then moves to the anode, creating a measurable current. Let us work through a typical exam calculation. First, find the frequency from the wavelength using C equals F. Then calculate photon energy using Planck's constant. Convert work function to joules. Subtract to get kinetic energy. Finally, express in both electronvolts and joules, a common unit switch in exams. Watch out for these common mistakes. Many students think brighter light means more energetic photons. Wrong. Intensity is about number of photons. Unit conversions are crucial. Always check you are working in joules or EV consistently. Also, remember that classical wave theory fails to explain the photoelectric effect's instant onset and threshold frequency. Examiners love that point. To wrap up, remember these 5 key pillars: the photon model, photoelectric effect equation, threshold frequency, wave-particle duality, and de Broglie wavelength. Master these, and you will bridge classical and quantum physics. Good luck with your studies.